Hi everybody, I am recording a video for those of you guys who are gone today. It's Wednesday, March 22nd. I'm starting off in the Schoology folder because I want to make sure that you're aware of what assignments I'm asking you to complete for today. You will be responsible for these, okay? First of all, take a look at our objective. The rest of this week, or in the previous, it was I know that substances change into other substances during a chemical reaction. Well, today I'm asking you to explain how that happens. Okay. Basically, today is the last day of the chapter 2 lessons. We're going to move on to chapter 3 tomorrow. We're going to do something a little bit different for the rest of the time. And so before we move on, I want to make sure that you're understanding the key concepts and just the ideas that we have going on in this chapter. So the activities we're working on, chemical reactions 2.3, and we're just doing activities 2 and 3 today. We're not going to do the warm-up, okay? You can make sure that you have the homework. Number 1, there's a model. It's called How Rust Formed. There's a digital copy in this folder, or you can come into my classroom and get a hard copy. The second thing is a CR Chapter 2 Scientific Argument. Again, the digital copy is in this folder. But if you want a hard copy, you have to come to my classroom. And then lastly, I want to make sure that you are studying your chemical reactions, vocabulary, and key concepts. Just a reminder that your test is going to be on Wednesday, March 29th. That's a week from today. All right, let's go ahead and get started with the lesson today. It's a short one. I gave the kids quite a lot of time to work on their lessons, on their assignments. And so let me just kind of breeze through this really quickly. If you remember, we had 3 different claims that we're working on. The chapter 2 question is, how did the rust form? And Dr. Yoon has 3 claims for us. The first claim is that iron pipes changed into rust. And so let me help you understand what that means. You know that the substances before a chemical reaction are called the reactants. And then what happens after a chemical reaction, those substances are called the product. So claim number 1 is saying that the iron pipes, or just the element iron, the molecules for iron pipes, they reacted by themselves. That was the reactant, and the product is the rust. Claim number 2 says the fertilizer is the reactant, and the rust is the product. And claim number 3 says the iron pipes plus the fertilizer yielded the rust. So the iron pipes and the fertilizer were the reactants, and the rust were the product. So we're going to go ahead and test these claims, and we're going to use tokens today. So the kids got 2 cups. One was labeled pipe substance, the other one was labeled fertilizer, and they had like all yellow tokens in the pipe substance. They represented the iron, and then we had different colored tokens in the other one for fertilizer, and they corresponded with the oxygen, the nitrogen, and the sodium that made up the sodium nitrate of the fertilizer. Okay, so we started with claim number 1. We took all of the tokens from the pipe substance. And remember, the pipe substance is iron. So it is only made up of iron. So I had the kids make an extended structure. Remember, it's a solid. It's only made up of iron. And so this is going to be, because they're a solid, the molecules are close together, they're vibrating in place. And so I just had the kids put together like 2 rows of whatever, 3 or 4 tokens each, and they were just really closely packed. That is an extended structure. Just a reminder that Dr. Yoon has sent over this key to help us remember what the formula or the chemical makeup of these molecules were. So the iron pipes were just made of repeating groups of iron. Fertilizer were repeating groups of the atoms NaNO3. And then rust was a repeating group of atoms of Fe2O3, or rust. Okay, so I had everybody, remember, they've got the iron pipes, so they've just got the yellow tokens. And then I said, okay, you guys, now go ahead and rearrange the iron pipe tokens and create a rust token. And it didn't take very long for everybody to realize you can't do that. And the reason why you cannot make rust from just iron is because what's missing? You're missing the oxygen atoms. So there's no way that the iron pipes by themselves can react and create rust. So if you go into activity number 2, in Amplify, there's a comment or a claim that says claim number 1, the iron pipes changed into rust. And then there's a place for you to determine whether or not that's even possible. So when you read a chemical reaction of the iron pipes and you click on that toggle switch, you'll see that it gives you a choice that it can form rust or it cannot form rust. And of course, a chemical reaction of just the iron pipes cannot form rust because it's missing the oxygen atoms. So then I had the kids put all the tokens back into the cup, and then I had them build one fertilizer model or molecule from the tokens in the cup labeled fertilizer. So that means they took out 1 purple sodium, they took out 3 red oxygens, and they took out 1 blue nitrogen. And I reminded them, I asked them what the definition of a molecule was. And a molecule, as you know, is a group of atoms arranged in a particular order. So they couldn't just throw all of those atoms together. We had to organize them exactly in this manner. So you've got the purple sodium right next to it, touching it, because by the way, if your atoms don't touch, it's not a molecule. They're just kind of hanging out. So you've got the sodium, and then you've got an oxygen molecule or atom right next to that touching. Then you have a nitrogen touching that. And then off the nitrogen, you've got 2 oxygens coming off the tail there. So that is 1 molecule of sodium nitrate. That's fertilizer. So I said, let's go ahead and build a fertilizer molecule. Everybody did it. And then I said, okay, now rearrange just that molecule and make rust. And very quickly, everybody said, wait a second, we can't do that. We have 3 oxygens for the rust, but I don't have any iron. Okay, so go into your activity number 2, and let's go to claim number 2, the fertilizer changed into rust. And of course, the answer you're going to toggle on there is that a chemical reaction of just the fertilizer cannot form rust. It's just chemically impossible. So keeping the fertilizer molecule, I had them pull out as many iron atoms as what they would need to create rust. And so they said they knew that they needed at least 2 iron atoms, 2 iron molecules. Okay, so they went ahead and they made their iron molecules. They added 2 of them. And then I said, okay, now try to rearrange those 2 substances and make rust. And of course they could. Keeping in mind that what they had to do is break apart the tokens of the fertilizer, and then they rearranged the 3 oxygen atoms with 2 iron atoms to make 1 molecule of rust. And then because atoms cannot be created or destroyed, we had the 1 sodium and the 1 nitrogen that was still there. We just didn't have any use for them right now because that's not what we're studying. Okay, so ultimately they made another substance. We're not studying that right now, so I'm not worried about that. So when you come back into the 3rd claim, and we can see that iron pipes and the fertilizer changed into rust, that's a chemical reaction between the iron pipes and the fertilizer that can form rust. So when we look at all 3 claims, the only possible claim that it could be would be, of course, claim number 3, that the iron pipes and the fertilizer changed into rust. And so the way that we would say that as a chemical reaction would be iron plus sodium nitrate yields iron oxide or rust. So the only way to get all of those atoms you need to build the group that repeats to form rust is to take tokens out of both cups. Now remember, this is not really atoms. This is a model, okay? So remembering then that in reality, the reactants would be iron, and iron plus sodium nitrate yields, and we could say rust, or we could use the chemical term and say iron oxide. All right, so this is how you're going to fill out the modeling tool. You are going to remember that we have key concept number 7. This is just a repeat. And I asked the kids to say this out loud because I'm trying to get you guys to study for your test, obviously, but then I'm also wanting them to understand what we just did and make that connection to the key concept. So during a chemical reaction, atoms rearrange to form different groups of atoms, which is what we just modeled. Good grief, sorry, my phone keeps going off. This model, let me explain how you're going to do it. If you've got any questions, you can ask me, okay? First of all, look at the top left. Remember, this is an atomic scale model. I do not want macro scale drawings of anything. We're looking at what's going on a molecular scale. Your goal is to make a model that explains how the iron pipes and fertilizer changed into rust. So we've got a box that is indicative of before, during the change, and after. And take a look at the directions down below. So in the before box, I want you to draw the iron pipes and fertilizer before they changed into rust. Again, this is the atomic scale model. So you're going to use the billiard ball models, and I've got a key over there on the right side. And the iron pipes would just be the yellow iron molecules. And remember, how many did we need in order to make rust? So go ahead and represent those over there on the before. And then also the fertilizer. And if you don't remember what it looks like, you can go back. I believe it's on page 3 that it has this, those molecules on there so that you can look back and reference what the arrangement of those atoms are for the molecules. So I want both the iron and the fertilizer there. Now, during the change, you're going to describe or draw the iron pipes or how the iron pipes and fertilizer changed into rust. And so when you have these nice molecules on the reactant side, what has to happen to them? What do you imagine the kids had to do with the tokens? And represent that there in that middle box. And then afterwards, the only substance that I'm really looking at as far as to grade is the rust. And so I want to know what does that molecule look like? Remember, a molecule is a group of atoms arranged in a particular way. So I'm looking at how you have them arranged. That's important. They can't just be lumped together. They have to be touching, otherwise it's not a molecule. They're just atoms that are close to each other. And then you'll have the sodium and the nitrogen molecules left over. You need to represent them, have them in the box, but it doesn't matter in what order because I'm not looking at those. I'm just looking at your rust. All right? Let me know if you have any questions about that. This is the scientific argument. The scientific argument is one that we are using to answer the Chapter 2 question. I've screwed up in that I copied the Chapter 1 question scientific argument, and I changed everything that I needed except for the actual question. So look down below, kind of 3/4 of the way down, you're going to see where it says Chapter 1 question. I need you to change that on your copy so that you say Chapter 2 question, and then cross out the Chapter 1 question, and above it you're going to write the Chapter 2 question, which is, how did the rust form? You can pause this video while you get that done. So when you're ready to write the scientific argument, I'm having a kind of a hard time with your class in general because I think everybody wants to either finish quickly or maybe you're not quite sure exactly what to write down. But it seems like the scientific argument is less of an argument and more of just like, I'm just going to put my opinion down. And so please be sure to follow the instructions. That's why I've circled that in yellow. Just really make sure that you follow those instructions and that you follow them step by step. Don't go out of order. Don't start with your key concept and then give me the evidence. Please make sure you follow the order. So step number 1, state your claim about how the rust formed. We all agree that claim number 3 is correct. But if you just write down, I agree with claim number 3, and then you move on your merry way and start talking about something else, I'm counting the whole thing wrong. You have to restate and answer. So just tell me, what does claim number 3 say? It says the pipe and the fertilizer changed to form rust. So just write that, put a period, and move on. Step number 2, use evidence. Where? From what kind of evidence? Use evidence from the token activity to support your claim. Use evidence from the token activity to support your claim. Don't pull out any other evidence that we talked about. Don't even, take real world evidence that you think would answer the question. That's not at all what we're doing. I want you to think about, why couldn't we make rust using just the iron atoms? And why couldn't we make rust if we had only the fertilizer molecule? Why couldn't we make rust? What were we missing? And why is it important that we have both of them? Number 3 says use one key concept to explain why the token evidence supports your claim. Hopefully you know which key concept that was. Here's a huge hint. We went over it in class. If you don't remember, rewind this video about 5 minutes and then hopefully you'll hear it. And then lastly, I always put a list of vocabulary words that I want people to use, and invariably people forget to use them. And so I'm kind of making this a part of the homework assignment, and that is, I want you to use all 6 of these vocab words listed in your argument. And then in order so that you and I both know that you use the vocab words, I want you to highlight it the first time you write it. So you can use these words in any form, singular or plural. And if you use the word atom 4 times, you don't have to highlight it all 4 times. Just highlight it the first time that you use it. So you're using the word atom, chemical reaction, model, product, and reactant. Remember, that's not a reactant, doesn't mean to react with. It means you're describing the substances that were at the beginning of the chemical change. What did we start with? And then the product is what we ended with. And then lastly, you're going to use the word substance. Okay? All right. I didn't give you a whole lot of room to write on this one because you really don't need it. It's pretty straightforward. There's not a whole lot that you have to use. If you find yourself lacking room and you need more space, just flip it over and write on the back. All right, you guys, let me know if you have any questions.